Well, hello there, everyone. This is KP the Math G coming up once again. This actually will be the third video of the day and probably the final one of the day. I did find out that you are taking your those of you who are in the AP classes, you will be taking yours on May the 13th. Unless that has changed, that's the date that I saw online. So we got a little preparing to do, don't we? Besides me having 126 videos, working on my 127th video, we still got a little ways to go, and I will put out as many as I can, believe me. So this is for your benefit, and I just love doing it, period. I love doing it. So anyway, let's get to the problem. This is a 2012 question number 2. It's a free response question. In part A, this is important for part C. We're going to do B and C. We did part A in the last video, so if you want to look at the 226th video, you may do that. I think it's the 126th video rather. Okay. You can, well, the last one that I did, you can find this answer right here. The area of this region R. This is going to be good for answering part C, but it has nothing to do with part B. So we're going to leave this answer up there for the time being. We're going to do parts B and C. It says R is the base of a solid. Each cross section perpendicular to the x-axis is a square. Now what is that? It's a square. Yeah, I like that it's a square. Okay. Squares are easy. In other words, if you were to draw, well, we're looking at volume here. Okay. We're going to write an expression without solving, and it represents the volume of all the sum of these squares. And my kitty cat has come in to join me for whatever reason. I don't think it's going to be to learn any calculus, do you? She is very curious. Okay. Well, no. Well, I guess she decided that she was going to leave. Okay, anyway. Alright, so each cross section is a square. You have two functions, y is equal to ln of x. And, by the way, it is perpendicular to the x-axis, so that's what we're going to do. So this part right here in purple, up to this point right here, is right here. We'll just do a partition here. And that cross section would be a square. That would come out probably about, if this is this tall, then this is going to be this tall coming out this way like this, and so on. The closer in you get, the smaller the squares are, but they'll build up, build up, build up. And then after this, okay, actually we're looking at this region 1 here, and then we'll look at this region 2. Actually, that's what we're looking at. Okay, so we're looking at this I subinterval here. That deals with ln, and we're going to simply square that. So we are actually going from 1 now to the x value. Don't do the y, only the x. This x value right here, we'll call it x sub 1, is 3.69344. So 3.69344. And that's what you got to know. You're going from 1 to this x sub 1, which happens to be 3.69344. And of course, this is ln. Alright, so ln of x is this purple one to this point. And you guess what we're going to do? We are simply going to square that. Of course, dx. Okay, we're squaring it. Alright, so that's what we're doing here. Alright, in addition to that, we are going from 3.69344, 3.69344, and we're going to the end. This partition here is going to go all the way. I can move that from this x1 to 5, x1 being 3.69344, and I can move it all the way to 5. That is going from, that's in dealing with this line, which is 5 minus x. So 5 minus x squared dx. It does say that it's perpendicular. We do have to write it this way. If it said it's perpendicular to the y-axis, we would have had to gotten 1. Yeah, we would have had to do it another way. Okay, so I mean, there's a different method for doing that, but this is perpendicular to the x-axis, which means we're taking this part from 1 to x of 1, which is 3.69344 for the umpteenth time, and then from x1 to 5. Okay, 2 partitions. That's what you're doing here. Okay. All right, and that's what it is. It is just that. Okay. You could designate this number, call it A. You can call this B if you want to. You can't call it X. We got XY here, so let's call it a different letter, okay? All right, so there's that one. And I thought maybe that I would need more room for that, but this is the answer here, okay? All of this together. All right, and you are adding this other area, this other volume. Actually, that's what the volume represents, okay? And it is, 3D. So when you have a 3D, so you say, ever how far out this is, it's going to be this far out this way too. It's going to make a square. Now, this slice, it's going to be a square slice. That's what it is. So when you sum up all those square slices, you have volume. The volume of this base here. This base R. Okay? Alright? Had they had said something like a semicircle, then we would have used 1/2 pi r. We'll make this r, okay, something like that. So it would have to have been a little bit different. Had it been a triangle, we would have had to use 1/2 the base times the height, and so on. So I mean, 1/2 the base times the height. Okay, so all sorts of different things, but square is usually the square is the most common one used, and it's the easiest one to do. Okay, all right, that takes care of part B. Part C, and I did want to, apologize. I wanted to think that I had to put B up here. I did not. So anyway, so what's happening here? Let's just make a little small model of this. Okay, here is a very short. Okay, so let's draw this picture here. Let's see, here's 1 right here. Okay, LN is going this way. Here's 5 over here, and the line is going somewhat like that. Okay, I know this is not even close to being drawn per scale. This is ln of x. This is y is equal to 5 minus x here. Alright, so what's happening here is that a horizontal line K. Alright, let's see if we can find a different color here. Alright, K is being drawn like this. I'm just going to dot the line, and this is line K. Alright, K is a y value, okay, and what it does, it splits this R it probably would need to go down a little further maybe to make it look like it's down, that it divides it up a little bit better. Let's see. Okay. Alright, I know I went up and down, that's alright, but this is line K. Alright, it divides this region into two equal areas. Okay. We have just found that the area of R is equal to, and I want to say we got something like 2 point something, so let me look it up again. 2.986. Okay, 2.986. Okay, so this is the area. Okay, so what we're saying is that this divides this in half. So half of this, so 1/2 of R is equal to 2.986 divided by 2. And if you just want to leave it like that, you certainly may. Alright, so let's see. Alright, this is a K right here. We know down here is 0. We know this part right here is Y is equal to, well, we already got that. Already got it, 5 minus X, and then ln of X. Okay, it is, let's see, I think it's saying that it is, let's see, so, well, horizontal line, it's running this way. Okay, so what we got to do here is we're going to take a partition right here, like that, like so. Okay. Alright, and we have to set up the problem, write an equation whose solution gives the value of K. Alright, well, we know that if we pick the top one, we would have to go to K and this Y value, which is 1.0 something, 1.0, that's the Y value, not the X value, 1.30656, 1.30656. Now this goes on and on and on, so this is not going to be exact because you round it off. Okay, to get more exact, you could start from 0 to K, and that's important. That's what they're wanting to do. Can you figure out the integrand here? Alright, so that's what we're talking about. We are talking about area. So we are subtracting the right area, the right curve, which is a line, minus this part right here. So we want to subtract off, we're taking away that part right there. Alright, so right here it is this length right here, which we will call, let's call it x sub 2. And we're going to take away this right here with this part right here. Okay, right there, which is x sub 1. Okay. Alright, x sub 2 minus x sub 1. But now x, we got to solve for x. So in this case, let's do that. We have y is equal to 5 minus x. So we're solving for x. I just want to interchange x with y. If I do that, this x is positive. And when I move this y over here, the y will be negative. So y 5 minus y. Okay. And that's just an easy, because it's positive on this side. Move it to this side, it'll be negative. Move the negative x to this side, it will be positive. So that's the way, that's a simple one there. So here we go. This is 5 minus y. Okay, and we're taking away, not ln, we got to solve for that. So here we go. Y equals ln of x. Remember how to get rid of the ln. That's just e. E to this side equals e to the y. So now x is equal to e to the y. So e to the y, right there. Now dy right there. Oh, by the way, it does equal half of this area. since we know that we divided the area in half, all right, so 2.986 divided by 2. I mean, if you want to just leave it like that, that's going to be perfectly all right. You're just looking for an area there, and that's it. All right. You want the integral, all right. The equation, the limits, and so on. Okay. You want to get this correct here. All right. That's what they're looking for. You want to get this correct, and you want to make it into an equation. Okay. You cannot just leave it like this. It's half of the area right here. Could you have gone from wow, whatever, from K to 1.30656? I mean, that is an approximation. 5 minus y minus e to the y dy. Certainly you could. But now the deal is, this would probably be more acceptable because you had to round this off. This is not an exact value here. Would you get away with that? Probably so. I wouldn't count it incorrect if you did that. So I know I wouldn't anyway. But the more accurate one is right here. Okay. We looked at this bottom area, is all we did, is what we're doing. This area is the same as this area up here, okay? It's the exact same, we're just looking at the area down here, which happens to be 2.986 divided by 2. The whole area is 2.986, right? So I'm just taking half of that. Alright. Well, that's easy enough, isn't it? Wow. Okay. Well, without getting into another question, that's really all I have for now. Wish I had more. But anyway, that's going to be sufficient enough. And if I run a real long video, close to 30 minutes, it makes it harder to focus on something like that rather than maybe a 15 to 20 minute video. Would be a little more feasible. I'm trying to cut those a little shorter so you can focus on one thing at a time rather than 3 or 4 things at a time. And this was 2 problems. I did 2 problems, but needless to say, it was something that was very doable in a short time. Okay, this is KP the Math G, getting ready to sign off. Please subscribe if you have not done so already. If you'd like to make a comment, please do so. If you would like to hit that like button, say that you like it. Yeah, okay. If you don't like it, then I'd at least like to know why you don't like it. So make a comment and say, I didn't like this because. And give me some kind of closure on that. Why did you dislike that? And I need to do better if I didn't do an adequate job. I trust that I know that everything's correct here, but there again, somebody else could do it a little bit better maybe. I don't know. But I'm doing my best, and I wouldn't have out going on 127 videos if I didn't care about whether you did well on this or not. Okay, this is not for my glory. It is all for you, and I don't mind taking up the time. I'm retired, so I got garden work to do at times, and I do that, and that doesn't take an awful long time. Everything's already planted, so all it's time for me to do is just wait for the rain to rain and crops to come up, and then see what happens after so many days. Okay. Well, anyway, enough of what I do beyond this. KP the Math G getting ready to sign off. Ladies and gentlemen, I appreciate every one of you, and you have a great, great day.